All right, so in the first video for this section, we found this piece right here, that the Laplace of t sine k ends up giving us 2ks over s squared plus k squared squared. These are some important Laplace transforms to know. And what's more important actually is seeing the right-hand side and being able to work backwards. So for example, if we were working a differential equation and we needed to find the inverse Laplace of this here, you would need to make sure that you can map that to this here and see that k is equal to 1. And so this would be equal to t cosine of t. Or for example here, seeing I have s squared plus 1 squared on the bottom, let's go ahead and split this up. So inverse Laplace of s squared over s squared plus 1 squared, 2s over s squared plus 1 squared, and 1 over s squared plus 1 squared. All right, let's go ahead and see if we can match these up. So this looks like this one here. This looks like this one here. And then this actually looks like this one right here. All of these with k equal to 1. So I have that this would be equal to, now I don't have the 2 in the front, so I'm going to say 1/2 k equals 1 sine of t plus t cosine t plus, all right, 2s, k is 1, plus t sine t, perfect. And then here again, I'm missing a 1, I'm sorry, I'm missing a 2, so 1/2 of this piece here, so sine t minus t cosine t. All right, let's see if we can combine anything with like terms. All right, I'm going to have just a 1 sine t. And then my half t cosine t's actually cancel. And so that's going to actually be my final answer for the inverse of this guy right here.